Hi guys, we're doing the homework on pages 25 and 26, and you totally, definitely, absolutely need your graphing calculator, okay? All right, so we're going to do this using linear regression. So the first thing you want to do is get your calculator and you want to type your data in by hitting stat and enter. Okay. So I typed my data in ahead of time and I'm using list 3 and list 4. You don't have to do that. Obviously, you can continue to use list 1 and list 2. All right, but I just wanted to save some time. All right, so once you have your data in, you would hit stat, arrow over to calc, and down to linear regression. Now, don't forget we want your diagnostics on so that we get the correlation coefficient. So you hit enter. And you want to make sure that these match the lists where you typed your data. So notice that I have to change mine because I put mine in list 3 and 4. Yours should probably be already in 1 and 2, so you wouldn't have to change that, okay? And I like to store my regression equation in my y equals. So I hit vars, arrow over to y vars, function, enter. And there is a shortcut for that. I just can't remember it. So I noticed that I'm getting a 0.977, which we would round to 0.98, think 98 cents, super close to $1, which means that this has a strong positive correlation. Strong positive. Okay. So they would like me to round my slope and my y-intercept. So I'm going to round those in my answers. All right, so I get y, whoops, what happened there? Don't know. Okay, add notes, scrolling. I'm not great at scrolling, let me tell you. Okay, here we go, there we're back. Okay, so y equals 1.7x plus 62. Round your slope to the nearest tenth. Good. Round your y-intercept to the nearest integer. According to the linear regression model in Part A, what GPA to the nearest integer would result in studying for 15 hours? So 15 hours is the x value or the input. So I would do 1.7 times 15 plus 62. And you can absolutely do that on your calculator. You get 87.5 nearest integer, so that's going to be 88. Okay, now justify your answer basically just means either show work or explain. And since I showed work, I'm done with that. A passing average is defined as 65 or above. Does the model predict a passing average if the student spends no time studying? Well, no time studying, that means 0. So that would be 0, comma, oh, the y-intercept 62. No, they would not. And we can just say that that's the y-intercept. 62 is less than 65. Okay. For each additional hour that a student studies per week, how many points does the model? Oh, per hour. So that would be slope because remember this 1.7 is really over a 1. So I'm just basically using the slope. So the slope 1.7 points per hour. Okay. How did I arrive at my answer? I used the slope. Okay, now remember that the correlation coefficient, that was 0.97, I believe. Let me just double check. No, 0.98. So that is a strong, absolutely really strong, not perfect. Perfect would be a 1, but that is very strong. Okay, create a scatter plot. All right, so now I'm going to use my data table to decide on my mins. Okay, so my lowest is 2, so I'm going to go with 0. My highest is 20, so I'm going to go a little bit above that at 22. My y minimum, my lowest was that y-intercept of 62, so I'm going to go to 60. And my highest was 96, so I'm going to go to 100 just to make it easier to count. Okay, so I'm using 0 to 22. And I'm using 60 to 100. You don't have to use the exact same thing, but you want to use something similar. Okay, so you hit window, and I'm going from 0 to 22. And it seems reasonable to me to count by 2s if I do that. And then my y's, I'm going from 60 to 100. And I think it would be reasonable to count by 5s. So I'm going to hit the word graph, but no, I have to go to second stat plot because notice I have the L1 and L2. You would be fine because you probably have your data in L1 and L2, but I have mine in L3 and L4, so I have to change this. And then I'll show you how to change it back. So it's actually kind of a good thing that you're watching this because you do have to know how to do all of this. And you'll be doing a lot of statistical graphing when you take Algebra 2. So here's my graph. And notice my line best fit or my least squares line or my line of regression, how wonderful it looks. I have 1, 2, 3, 4 points above, 1, 2, 3, 4 points below, and 2 points that actually go through it. So this is a really, really good line of regression. Okay, so that completes page 25, and I'm going to go on to page 26. Okay, so use your calculator to determine the equation of the line best fit. So back I go to my calculator. Now I did enter this data in my L1 and L2, so again that's ready to go. I'm going to clear this out because I don't need it anymore. Just a little housekeeping. Okay, so stat, arrow over to calc, and you're doing linear regression. And I do have to change back to my L1 and L2. You probably don't, but it's real simple. See, anything you want to get in blue, you hit the second button. And I'm going to store my regression equation, vars, y vars, enter, enter, there it goes, and calculate. Okay, see now notice my slope is negative. Because my slope is negative, my correlation coefficient is also negative. Now, it's not as strong as the last one, but 0.9 is very strong, 90 cents, very close to $1. Okay, the sign of the correlation coefficient will always match the sign of the slope. All right, so here we go. I'm going to copy this onto my paper. So I get y equals negative 0.005 because they want it to the nearest thousandth, x plus 65. Okay, what does the y-intercept tell you about the temperature in Nebraska? So now remember, that's when the x is 0. So basically we're saying that at 0 elevation, and that's sea level. At 0 elevation or sea level, the predicted temperature is 65 degrees, and that's in Fahrenheit. Okay, Using correct units give an interpretation of this slope. Okay, I like to use for every. I just like the way that starts. So for every foot increased, and notice I'm using my units, correct units. Every foot increase, the mean temperature will decrease. Now, you don't put a negative because you use the word decrease. The word decrease is the negative sign. Will decrease by 0.005. Very little, very little. 0.005 degrees Fahrenheit. Okay? When you're talking about slope, use ratio words for every, for each, per. Okay. Using your model from part A, what would be the predicted temperature of an elevation of 3,000 feet? So we're going to substitute. So basically x equals 3,000. So y equals negative 0.005, plug in a 3,000, plus 65. Okay, so that ends up being 50 degrees. And it's Fahrenheit. So you really should put the F. It's just good practice to label things. Would you characterize this correlation as being positive or negative? Negative. The slope is negative. And remember, the correlation coefficient is also negative. Okay. Create a scatter plot of the data and graph the line best fit on it as well. So we're going to use the calculator for that, and that's okay to use the calculator. A lot of times you're not actually asked to make these graphs because they take a lot of time. So you're usually asked to like match them or identify them. If you have to make them, you'll make like one out of like 15 questions. You would make one. Okay, so I have my line of best fit already in my y equals. I have to hit second stat plot. Now for me, I have to go back to my L1 and L2. You probably already have your L1 and L2 in there, but remember on the prior question, I had used lists 3 and 4. It's completely up to you. All right, so now my window. When you're looking at your window, you always want to go back to your data table and you want to go using your range. So you go a little bit lower, a little bit higher for the domain, a little bit lower, a little bit higher for the range. Okay, so my lowest number was 1,200, so I feel comfortable with 1,000. My highest number was 6,328. So I feel very comfortable with 6,500. And I'm going to count by hundreds. If I was making that graph, I would probably count by like 500s or something. But 100's fine. Okay, my lowest y is 32, so I'm going to go with 30. And my highest y is 62, so I'm just going to go with 65. Okay, I'll keep the counting by 5s. All right, here's my graph. It looks pretty good. Now, you notice that there's 3 above and 4 below, and that's, the other one was a little closer because it had a higher correlation coefficient. Your correlation coefficient tells you the strength of the relationship, so it will also tell you how close those data points are to that line. There is another thing we do called residuals, and I'll talk a little bit about that on another day, but we're really not getting that into it this year. So now you'll notice that there's this one point, I wonder if I can write on here. I can't, but maybe you see that I'm like touching it. Okay, I don't know if you can, but there's this one point up here that hopefully you can see. That point is far away and it missed the model, and it would have what's called a high residual. So yeah, there is one point. It's not an outlier, that's different. It's just something that doesn't fit as well. An outlier is an extremity. This is a little bit different. So yeah, it's a little bit away from, and that point would be 5625, comma 48. All right, I hope you understand this. I hope you're doing well. Take care and say hello.